Hey, this is Simon Maselli. I'm the General Manager of Minnovation Australia. This recording has been made for the Smart Cities and Suburbs program, the Northern Melbourne Smart Cities Network. And this video will cover the topic of network management and it will provide an overview of the components required to manage an IoT network. In this video, I am hoping to change tempo and explore the software layer of LoRaWAN and more specifically the network server. My name is Simon Maselli and I am the founder and general manager of Minnovation Australia. The context of this video will cover the Northern Melbourne Smart Cities Network project. This project has been a collaboration between 5 local councils, 2 universities and Minnovation, and has been funded by the federal government's Smart Cities and Suburbs program. You can learn more about the project by visiting the first video in the series presented by Akram Hourini from RMIT. This video will cover 2 key topics, the network server and device authentication. At the end of this video, I have included a glossary of terms, so if you do get overwhelmed at any point, please feel free to skip ahead and review these items. Feel free to go back and forth as much as you need to understand the topics presented. I'm sure viewers of the previous videos in this series and other LoRaWAN enthusiasts will have a general understanding of LoRaWAN topology. But for those of you who don't, here is a quick overview. Starting from the left-hand side, we have our devices. Devices, which are sometimes referred to as nodes or sensors, are the hardware that create tiny packets of data for use in the end applications. These devices have onboard sensors that are used to create the messages that are transmitted over the LoRaWAN protocol to a gateway. Gateways are also referred to as concatenators or packet forwarders. While there are some small technical differences in these terms, for this video they will be referred to exclusively as a gateway. Gateways perform a relatively simple function. They receive the raw LoRaWAN message or packet and forward it to the network server. The network server receives the packet, decrypts the raw message and adds metadata about the transmission. This metadata includes signal to noise ratio, received signal strength indication, timestamps, and a whole lot more of other useful information. Important misconceptions is that the network server is used to store information. This is not so. Generally, data will be stored by the end-use application and not by the network server. It is also a common misconception that the network server is used to control and make changes to gateways and end nodes. Again, this is not entirely correct. The network server holds that configuration information, but most of the time an alternate method of configuring these end devices is required. Information is collected by the network server and then forwarded to the application server shown on the right side of this diagram. Depending on this application, information may be forwarded to another application or consumed by the end user. There are lots of providers of LoRaWAN networks. For example, the Things Network. TTN is a set of open tools and global open network to build IoT applications at low cost, featuring maximum security and ability to scale. Sigfox is an inexpensive, reliable, low power solution to connect sensors and devices. It is ultra narrowband and a commercial operator. LoRaWAN is a network service provider with the largest global public infrastructure. They offer free public as well as a professional integrated solution. And XMesh is Minnovation's proprietary network that makes LoRaWAN gateways redundant by removing gateways and decentralizing the network's architecture. XMesh is our proprietary offering for LoRaWAN networks. It uses a mesh topology, or more technically, a cluster tree topology for communications as opposed to a star or spoke and hub topology, as used by other network operators listed above. The cluster tree approach provides several advantages over star topology, particularly in environments using LoRaWAN for non-critical automation and control and bidirectional communications. But for the purpose of this video, we're going to review star topology networks. And there are also differences in the providers. So let's explore some differences between TTN and Sigfox. So range, for example, rural coverage expected from the TTN is approximately 10 to 15 kilometres in good conditions. In Sigfox, that under those same conditions, the expected maximum is 30 to 50 kilometres. And in urban environments, the maximum range of TTN is about 3 to 5 kilometres, and Sigfox, under the same conditions, is about 3 to 10 kilometres. So Sigfox claims better performance in range and also in very dense environments, and that's mainly due to its extreme narrow band. Both of these providers have security. The TTN uses AES 128-bit. Sigfox employs a token and firewall approach. Power consumption is also very similar. So TTN is slightly lower with a peak performance of 44 milliamp versus 49 milliamp for Sigfox. And sleep of both protocols is about 1 microamp. So very, very similar in terms of their power consumption. But data rate, there is a large difference between the two protocols. So the data rate of Sigfox is about 0.1 kilobits per second, and TTN has data rates of between 0.3 to 37.5 kilobits. So TTN can transmit much larger packet sizes. And coverage is also an important factor. So the TTN is available in approximately 100 countries in both public and private configurations, where Sigfox provides scattered coverage in approximately 45 countries. So to bring things back to the context of this video, the Northern Melbourne Smart Cities network project, the TTN was chosen due to its best fit on packet size and the pseudo adoption of the Smart Cities protocol for Australia. For the remainder of this video, we will refer to the TTN as the LoRaWAN network server. Particularly the TTN in Australia. Australia is a big country, as you're aware, and it can be challenging setting up country-wide services. So as of November 2019, the TTN in Australia had 43 communities with over 500 gateways in service. And in Australia, the TTN uses two LoRaWAN band plans. There is AU915, and more recently, the AS923 band plan has become popular. You can visit the website www.thethingsnetwork.org/docs/LoRaWAN/frequency plans for more information about those band plans. What is a network server? The network server provides two key functions: authentication and authorization of devices, and management and optimization of the network. The network server receives messages from devices, managing device authentication, application message routing, and management of gateways and devices. It will dynamically select the best gateway for device routing, as well as deduplicating packets and optimizing radio resources via the ADR function. So if we review LoRaWAN data, it begins life as a wireless LoRaWAN transmission from device to gateway. There it is sent via a communications backhaul, such as cellular or Ethernet, to a network server in the cloud. The network server performs the functions necessary for LoRaWAN to work before forwarding the data to the appropriate application server for processing. The data is encrypted along the whole journey, firstly by the network session key, NetS key, and then via an application session key, AppS key. So what that means is the data generated by the server is first encrypted by the network session key. This is from the device to the network server. And the data generated is protected from the node all the way to the application server shown here. That is protected by the secondary level of encryption, the app S key. Note that in reality, there is another server called the join server, which assists the network and application servers during the join process. It provides security functions important to manufacturers and device makers, but needlessly complicates the picture here. So the LoRaWAN network server provides or supports two activation methods. The first activation method is called over-the-air activation. And the second is ABP, or activation by personalization. So ABP involves pre-provisioning devices to operate on a given LoRaWAN network, and they're defined by its network ID. Devices are configured with network and application session keys, along with pre-allocated 32-bit network device addresses. The IP analogy of this scheme is a static IP address. Over-the-air activation requires devices to send a join request to a network server, and if authenticated, will allocate a device address and a token to derive session keys. The network and application session keys are derived during the join procedure from a shared app key pre-provisioned on the device. OTA activation provides a high level of security, and addressing is analogous to the allocation of an IP address via DHCP. So this raises an obvious question. Do I use OTAA or ABP? So with care, either method can be just as secure and effective as the other. But a rule of thumb is OTAA is generally the easiest way to achieve some basic security and flexibility when it comes time to deploy. ABP is more likely to be useful in the prototyping stage where you need complete control over the activated devices. Either way, remember that unless you're doing an OTAA join before every message, you have to keep your frame counter up to date for subsequent messages to get through. When choosing a device for the Northern Melbourne's IoT network, please consider the following. The device needs to be the Things Network compatible. The Things Network has a great community-driven support network around it, and there are a great number of forums and places you can go to get information and assistance on getting your device online quickly. Second consideration is to ensure that device is compatible with the 915 MHz subband. We found, and it's our experience, that devices on this subband are better quality and provide a better overall quality of service for the network. So when selecting your device, please consider those two elements and you'll be online in no time. So my name is Simon Maselli. I'm the General Manager of Minnovation Australia. If you'd like more information on the information that I've just presented, visit our website, www.minnovation.com.au. Find us on Facebook, LinkedIn or YouTube, Minnovation AU. Do a search, find us there, join us, follow us, whatever you need to do to get the information that we send out regularly. Again, thanks for listening to this presentation. My name is Simon, and I'll talk to you next time.